Hello. I am in the mood to do some maths, and I did this amazing question, which I found very interesting, and I wanted to share how to do it, or at least my attempt at how I did it. So the question is, how many solutions are there to 1 over x minus a plus 1 over x minus b plus 1 over x minus c plus 1 over x minus d is equal to 0? And then the next part of the question is to show that the sum of the solutions are 3 or 4 a plus b plus c plus d. Now, there are a few things to notice. The first thing is that we do not know what nature are these solutions. Are these solutions real numbers? Are these solutions complex? In reality, because the question doesn't specify them, this is not something that I have to be concerned about. The next thing is that the second you hear about sum of solutions, or where the solutions in this case are the roots of something, they should bring back Vieta's formulas. Or if you do A level further maths, roots of polynomials, which is kind of the idea we're going for. Okay, so the first way I the first and only way I thought about doing this question is to get rid of the denominator. The way we do this is by making everything into a single fraction. So I know my denominator, if I am to combine or like everything, is going to be just not a x minus a times x minus b times x minus c times x minus d. And for instance here, we are multiplying by x minus b, x minus c, and x minus d. So here we're going to have x minus b, x minus c, and x minus d. Here we're going to have the same thing, except we won't have x minus b, but rather x minus a. The same thing with this fraction, but we won't have x minus c, but rather the missing one out of the three. And the same thing with 1 over x minus d, where we won't have x minus d in numerator, but we will have every other denominator. So at the end, this is going to look like something like this: x minus a, not x minus a, already went wrong. X minus b, x minus c, x minus d, plus x minus a, x minus c, x minus d, plus x minus a, x minus b, and x minus d, and lastly plus x minus a, x minus b, and x minus c, all equal to 0. Now, how to proceed from here? Now, given that our denominator is not 0, we can actually multiply both sides by denominator, and we are left with a polynomial in my as my uh, result. And I'm going to try my best to copy it down as fast as I can. And I know this might be quite painful to watch. I did buy a new writing pad just for preparation for interviews, and I am kind of liking it because I can directly write onto my iPad, which not iPad, computer, which is so cool. Okay, now what is the degree of this polynomial? The degree of this polynomial is going to be a cubic, because what we're doing is adding one cubic plus another cubic plus another cubic plus another cubic. So we have 4 cubics, and if we add them up, we are going to have one other cubic, because cubic plus cubic is cubic. So I'm gonna give a name to this. I'm gonna call this g of x. G of x is a polynomial of degree 3. This implies that we are going to have 3 solutions. Now, we do not know whether the solutions are real, but we can have either 3 real solutions, 1 real solution, plus 2 complex conjugate ones. Now, bear in mind, if you look at the graph of the typical cubic, you can either have this, or this, or this, and of course you also have its negative versions where it actually starts from here instead of here. But yeah, these are all the possible configurations, if that's a word I can use in this context, of roots that cubic can have. So 1 real solution plus 1 repeated real solution. So these are all the configurations, pretty much. Now, on to the next part of the question is that we need to show that the sum of my solutions is going to be 3/4 of a plus b plus c plus d. Now, this seems to be quite an interesting problem because we ought to expand all this entire thing out, and quite frankly, it is what 10 o'clock in the night, very tired, and it's an incredibly tedious job, even if I am not tired. So what I'm going to do is to work out the relevant um, the relevant coefficient. Because at the end of the day, what we're looking at is the coefficient of my polynomial. So if I have a standard cubic, so ax cubed plus bx squared plus cx plus d, my sum of my roots is equal to minus b over a. So what we want to find is, we want to find what a is and what b is. This is not the A and B in the problem. I should have probably used different letters. But yes, so we need to find a coefficient of x cubed. The coefficient of x cubed in this case is going to be 4 because I'm going to get 1x cubed here, 1x cubed here, 1x cubed here, and 1x cubed here. So I know that my A in this case is 4. So now I'm left to work out what b is. So the sum of my roots, the coefficient of my my x squared term. So how am I going to work this out? Now, if you think about it, I can turn all of this into a single, what into a quadratic times a cubic. So if I do that, so let me first get rid of this and that. Okay, so I'm gonna bring this down here. Um, okay. Oops. I cannot use this. Yes. Okay, finally. Um, I can rewrite this as the following. As x squared minus x b plus c plus bd, which is irrelevant in this case, times x minus d, plus x squared minus x a plus c plus ad times x minus d. And notice I can factorize these two out, and I will do that later. X squared minus x, was it a plus b plus AB x minus. Surely this is not minus d, is it? Yeah, it is minus d. Oh, that's weird. Hold on. Something is off. No, I don't know. And x squared minus x a b, no, a c, a plus c, a c x minus b. Okay, so I think something is wrong. So here the only term that should be missing is a, b, c, and d. Now it is correct. Um, so I have three. Oh, I guess like the order matters. What I can do is perhaps this might be better. I can change this into this my which one? 1, 2, 3 x plus d, and have my b here. So from this line, I'm going to have the coefficient of x cubed is going to be from this line here. So a. I'm either going to have no, sorry, x cubed. Sorry, x squared. We already know x cubed. So we have minus d because we can have, oops, we can have this times this, or we can have this times this, and minus b plus c from this line here, plus minus d again, minus a plus c. And then from my second line, the coefficient of x cubed is, I can multiply this with this, so I have minus b, a plus d, minus a plus d, plus minus b, that's not b, minus a plus c. Okay, interesting. I have two a plus c's. I don't think it should be a problem. But if I combine a and b, my two lines, there are way too many a and b's. Okay, that might be confusing. I'm gonna be left with minus 2d, minus b, minus a, minus 2c, minus 2b, minus 2a, minus a, not minus a, minus d, and minus c, which brings me into a total of minus 3 a plus b plus c plus d. Now remember, we are looking for minus the coefficient of x squared over the coefficient of x cubed. Yeah, and therefore I am going to be left with the following: minus 3 a plus b plus c plus d over 4. The negatives are going to cancel out, and this is the same as 3/4 of a plus b plus c plus d, and hence we have shown as required. Very nice problem. I very much enjoyed it, and it's a very interesting one if you want to look at the very basics of like algebra and Vieta's formulas. But yeah, I really enjoyed doing this.